Hello students, let us continue the chapter nitric acid and we are going to study about its properties. Physical properties of nitric acid. Pure nitric acid is colorless fuming liquid having a pungent odor, and impure acid on standing develops yellow color due to the presence of dissolved oxides of nitrogen. It is completely soluble in water and forms a constant boiling mixture with water. Pure acid has a density of 1.54 grams per milliliters, as the density of constant boiling mixture is 1.4 grams per milliliter at 20 degrees centigrades. Anhydrous nitric acid boils at 83.6 degrees and freezes to a white solid at minus 41.7 degrees centigrades. It has a corrosive action on the skin and causes yellow blisters due to the formation of an acid called xanthoprotic acid. Now about the constant boiling mixture. It forms a constant boiling mixture with water containing 68% acid. This mixture boils constantly at constant boiling point because without any change in its composition. At this temperature, the gas and the water vapor escape together, hence the composition of the solution remains unchanged. So, nitric acid cannot be concentrated beyond 68% by distillation of dilute solution of HNO3. Next, we will move on to the chemical properties of nitric acid. So, chemical properties of nitric acid. As we know that nitric acid is a strong oxidizing agent. When it undergoes thermodecomposition, it yields nascent oxygen as is shown in the reaction. HNO3 yielding water, nitrogen dioxide and nascent oxygen. And we see the behavior of nitric acid with metals, non-metals and all due to that nascent oxygen. With metals, nitric acid behaves differently with different metals at different concentrations. With sodium, potassium and calcium, the reaction is highly explosive. With magnesium and manganese, it will react in a very dilute form, very dilute form that we are going to see in the coming reactions. First, with metals like iron, aluminum, cobalt, and nickel, these metals become passive, they are inert due to formation of a layer with pure concentrated nitric acid. The reason is given over there, the formation of extremely thin layer of insoluble metal oxide results in their passivity. Passivity can be removed by rubbing the surface layer with sandpaper or by treating with strong reducing agent. Now, dilute nitric acid is generally considered as a typical acid except for its reaction with metals, since it does not liberate hydrogen. Other acids, yes, we know that they liberate hydrogen when they react with acids, but over here means metals, and over here they react with only manganese and magnesium in a very dilute state to liberate hydrogen. Here it is very dilute, about 1% acid. Nitric acid reacts with magnesium and manganese at room temperature to give the nitrates and hydrogen gas. Reactions are Mg plus 2HNO3 gives MgNO3 whole twice plus 2, and similarly with manganese. These reactions prove that nitric acid contains hydrogen. In the other cases, the hydrogen form get oxidized to water. That is why nitric acid is not used. With metals like copper, zinc and iron, and the reaction with cold and dilute nitric acid, they form the respective nitrates and nitric oxide gases obtained. But with concentrated nitric acid, or hot and dilute nitric acid, the reaction is a little different and they form nitrates of course, but over here we see nitrogen dioxide coming out as a product, but in the earlier case we saw nitric oxide or nitrogen monoxide was obtained. Now, reaction with nonmetals. HNO3 oxidizes nonmetals and reduces to NO2 as it is seen in the reactions. Sulfur forming sulfuric acid and nitrogen dioxide is obtained. With phosphorate forms phosphoric acid and nitrogen dioxide, and with silicon forms silicon dioxide and nitrogen dioxide. Acidic properties of HNO3. HNO3 is a strong monobasic or monoprotoic acid, provides only one H plus ion or hydronium ion. It neutralizes alkalis or bases to give salt and water as seen in the reaction. All acids do that, and it's called neutralization reaction. HNO3 plus NaOH gives NaNO3 plus H2O. With alkalis, as we have seen, it neutralizes the alkalis to form salt and water, as you can see from the reaction. K2O plus HNO3 gives KNO3 plus H2O, and other alkalis like NaOH plus HNO3 gives NaNO3 plus H2O. Reaction with carbonates and bicarbonates, obviously like the other acids, they also give carbon dioxide and water along with the salt, nitrate salt. Action with metallic sulfides and bisulfides, as with the other acids, these the nitric acid with dilute nitric acid also the same thing is observed, that is sulfur dioxide and water is formed along with a metallic nitrate. Reaction with aqua regia. Now, reaction as aqua regia. What is aqua regia? Aqua regia is a mixture of concentrated nitric acid, 1 part by volume, and 3 parts of concentrated HCl, and gives a mixture of aqua regia which is called royal water. It is called royal water because it has a tendency to react even with noble metals like gold and platinum to give their chlorides. Aqua regia contains nascent chlorine which attacks these metals, as you can see from the equations. Pt plus 4Cl gives PtCl4, Au plus 3Cl gives AuCl3, etc. Effects of heat on nitrates. Sodium and potassium nitrates, they are heated. When they heat, they decompose on heating to give oxygen gas, which can be observed when you bring a glowing splinter near them, it will burst into flames. All other nitrates except those of silver and mercury decompose into the oxides, nitrogen dioxide and oxygen. As you can see, calcium nitrate forming a white color compound CaO and NO2 is liberated. With zinc also, it forms a solid which is yellow when hot and white when cold. That is zinc oxide of course, and reddish brown color gas NO2 is observed. With lead nitrate, yellow color solid is seen which fuses with the glass, and with copper nitrate, a black color solid, that is of copper oxide, is observed. With silver and mercury nitrates, they decompose to form the metal along with nitrogen dioxide and oxygen. Ammonium nitrate decompose explosively, leaving behind a residue. So, in the previous case, silver and mercury nitrates are kept in dark red bottles, so that to avoid their decomposition into metals. Next, we are going to see about the test for nitric acid nitrates. Kong nitric acid gives brown fumes on heating. Nitrates other than potassium, sodium and ammonium produces reddish brown fumes of nitrogen dioxide. On adding copper to HNO3 or acidified nitrates, dense reddish brown fumes of nitrogen dioxide are evolved. You can see in the reactions. Cu plus 4HNO3 gives Cu and NO3 whole twice plus H2O plus NO2. Now brown ring test, a famous test to identify nitric acid. Nitric acid is taken in a test tube, and then this is then freshly prepared ferrous sulfate solution is added. Then conc H2O4 is added carefully down the sides of the test tube. We see a dark brown ring of hydrated nitrates of ferrous sulfate. Over here, we should be kept in mind that freshly prepared ferrous sulfate solution should be used. Otherwise, it undergoes aerial oxidation, get converted into ferric sulfate, and the test tube should not be disturbed, or else the brown ring will dissolve in the layers of liquid. Now, some uses of nitric acid. Commercially, it is used in the manufacture of fertilizers. We all know this. In the manufacture of explosives like TNT, nitroglycerin, then as rocket propellant. Then in the manufacture of artificial silk dyes, plastics, purification of gold and silver with aqua regia, and purification of silver nitrate, which is used in making of photographic films, and an important reagent in the laboratory. So with this, we come to an end of chapter nitric acid. Thank you.